cylinder by each other and by the wall. Assume you know the direction of the normal between the cylinders. Okay, that's good for us to know. Assume you know. Okay, so what, let's start in the back, we'll go around. John, so what information is given that's not shown in the picture?
The masses and diameter.
Okay, so mass of 5 kilograms, and what's the first thing I'm going to do? Find the weight.
Yeah.
Right? So the weight would be 5 times 9.81. What's that?
Oh, did you essentially, is it okay if we just said times gravity?
5 times g?
Yeah.
That's what I just did. Yeah, but in the end, you're going to need numbers, right?
Yes.
So
but
find
not
the numbers.
for-
But I'm not going to take off if that's what you're asking. But what is it? What's the number?
49.05.
Say it again.
49.05.
And it would be newtons. And then the mass of B is 25 kilograms, and that turns out by 5, right? So what does it come out to be?
245.
Say it again.
245.25.
Okay. Anything else given? They give you the diameter of A is 100 millimeters. Diameter of B is 200 millimeters. Anything else, do you think, that's in the words that's not in the picture?
Direction of the normal.
What was that?
Direction of the normal.
Good, that the normal is, assume the direction. So we know, you don't have to write this, but we know the direction of normal. Okay, what do they want us to find? Determine forces acting on the cylinder by each other and by the wall. So let's start taking a look at the picture. And for me, again, it's always helpful to just draw right on there as scrap. So what things do we see in here? We know there's a weight, right? A weight of A. And we know there's a weight of B. Daniel, what else do we have here?
Well, we also have another force, the normal force.
Okay, give me one of them.
The normal A perpendicular to the surface.
Okay, so if I'm analyzing A, it's going to go towards A, right? So normal A. Did everybody call it N sub A?
Call it wall or NWA.
Okay. Make it the shortest possible. NA, done. I don't want to write W's throughout the whole problem. Okay, what else? Cameron, another one?
The normal of B to the floor.
Okay, normal of B to the floor. And we're really looking at the floor to the B, right, if we analyze B. So if I call that NB, is there another NB? Where? This way. So what did you call them, Cameron?
The bottom one was NB1 and the side was NB2.
NB1, NB2. Anything else, Ivan?
Switches between the two cylinders.
Right, and what are those?
They just cancel and I just put normal.
Normal, they're normals, right? So let's say normal. So there's normals in here. What did you call them?
Just normal 1 and normal 2.
Okay, how about NAB? Because it's between A and B. If I use A and B, then I kind of remember which one's on where. So if we find, so let's see what it's asking. Determine the forces acting on the cylinder by each other and the wall. So what do they want us to find, Mike?
They want us to find the magnitudes of normals.
Okay, so give me the variables. Now that we've defined the variables,
And
I don't want to write the magnitude of the normal by the wall. It's just too much.
yeah,
So what do I write?
NA, NB1, and NB2, and NAB.
Good. Okay, so let's do our table now. I'm going to write it small so I can fit it. Force, magnitude, direction. Brandon, what should I put in here?
For forces, you have WA, WB, so weight A, weight B, and then all the normals, normal A, normal B1, normal B2, and normal AB.
Okay, and what about magnitude? What do we know?
Magnitude, we know the weights.
Do we know any of these?
The normal AB, no, we don't know any of the magnitudes of those.
Okay, how about the directions of the weights?
The directions we know, the weights,
Okay, how about all the normals?
all the normals we know.
We know all of them. Okay, so how many unknowns do I have now, Hector?
4.
4 unknowns, which means how many equations do I need to solve it?
4.
4 equations. So in some of the homework problems, let's finish this. So Hector, we had 4 unknowns, we needed 4 equations, they're 2-dimensional bodies, so how many bodies do I want to analyze?
2 bodies.
2 bodies. And what did you analyze?
A and B.
Okay, body A and body B. So let's just draw them. So you mind, I'm just going to draw them? NA. We have the weight of A. We have the normal of AB. And it's known. So I'm going to call it theta, but we know it's known. Then I have my weight of B. I have my normal of B, you see, normal of B1, I have normal of B2, and I have the normal of AB, and this is theta. Okay, do I have all my forces labeled? Yes, and I probably would come through and write down what this is. So when I look at the picture, I don't just see a variable and think I don't know it. I also like to circle the things I don't know, because then they stand out to me. Okay, so all the forces are labeled. Do I show all the magnitude and the directions? All the magnitudes are shown and the directions shown. These are all in the X and Y axis. The angle here. So what's missing from this free body diagram? Yes, so I need to put an axis.
And a label, right?
So, say that.
You have to label them,
Label what?
the,
The axis?
the diagrams, the free body diagrams?
Oh yeah, that's right. You should label the break. Free body diagram A. Excellent. Free body diagram B. And why do I want them labeled?
So we don't mix up our bodies.
So when later on you set up all your equations, you know which equation, I know which equation is coming from which body. So in this case, how many unknowns are in this body? 2. Can we solve for it?
Yes.
Yep.
How come?
We have the forces in the X and the Y.
Because we have 2 equations. So in this body, we have 2 unknowns, assuming, they said assume that we know it, so it must be given somewhere. Okay. Oh, it's based on the distances, right? Because we have 100, we would do some geometry here, but we know this value. If this is a 2-dimensional body, I have how many equations from this body? 2. I only have 2 unknowns. Can I solve both of them? Yeah, Angelina?
Is it important to draw a circle instead of like one?
No, you could have just drawn a dot. Why could you just draw the dot?
Because they're concurrent.
Because they're all concurrent forces. Good reminder. They're all coming to the center. It's all concurrent. You just draw a dot. Okay, how about this one? Let's say I went and started solving the equations here. Would I be able to, without doing this, would I be able to find these 3 unknowns from this free body diagram?
No.
Why not?
You only get 2 equations.
Because you only get 2 equations from a 2D body when all the forces are concurrent. So where would you want to start doing your equations? Free body diagram A first. Okay, solve for these and you plug them into here. Did anybody do a free body diagram of both bodies together? Let's practice. Take out a piece of paper. Let's do a free body diagram of both together.
Did you say they're all unknowns and 3
Matt,
Joanne, for free body diagram B, can you say that there are only 2 unknowns if we are to assume that NB1 is equal and opposite to theta B?
okay, everybody listen to Matt's question? Ask it again, Matt.
can we assume that there are only two unknowns for free body diagram B if we say that NB1 is equal and opposite to the weight of B?
Okay, so everybody look up here.
No?
Okay, how come? Tim, I see you shaking your head, no, why?
Because we also have from the weight of A, like showing through the normal bag, pushing down.
Right. Because if you look here, we're looking at all the forces in the Y, and there's a weight B and there's a normal B1, true, but there's also a Y component of this force in here, right? So that means when you sum up the forces in the Y, you're gonna get one equation with two unknowns in it. Tim,
Can you say that NA and NB2 are equal and opposite?
can you say that NA, free body diagram here,
So NA and
can
NB2.
NA equal NAB?
NB2.
The two wall normal vectors.
Well, let's try, because if we have two different free body diagrams, and this unknown is in this free body, this force is in this free body diagram, and this force is in this free body diagram, you cannot put them together in your head. You could only establish equations from here and equations from here. But perhaps, when we draw that free body diagram, we could say that. Okay? So let's draw this free body diagram. What should I have? Gonzalo.
The weight? of
Which
NB?
one?
Both?
Good. I thought I just grabbed a new pen, but I didn't. So, weight of A and weight of B. What else?
Normal for B1 and B2?
Okay, normal for B1 and B2. Normal B1, normal B2, and?
The normal for B for A?
And the normal for A. I have my axes in here. Do I show all my directions of my forces? Yeah, we're kind of lucky they're all at X and Y. I don't have to show any angles or ratios. Okay, so Tim, now what equation do you want?
Some of the forces in the X.
Okay, some of the forces, so what's known? This is known and this is known, right? This is unknown, this is unknown, and this is unknown. So if we do some of the forces in the X, we just learned that these two are equal. How about if we did some of the forces in the Y? David, you have a question anyway, but I'll have you answer my question
Okay.
first, then I'll
Are you
answer
forgetting
yours.
the normal between A and B?
Say it again?
The normal between A and B?
So what happened to that normal between A and B? Are they there?
Okay.
They're still there, but they're balancing each other and they're canceling out. What have I always said? What's the adjective for this force now? It's internal. Because they're still touching and they're feeling each other, they're just they're equal and opposite. But now, David, can I do a sum of the forces in the Y?
Yeah.
And what would I find?
The weight A plus weight B
Equals?
equals 0.
Look at all the forces in the Y. If I did this, sum of the forces in the Y equal? Give me the equation.
Weight A?
But it's a negative, no?
Oh yeah.
So you can put a negative first. I just don't like putting negatives first, because then I put a negative next to an equal sign, and then I forget there's a negative there, because there's too many lines. So I always start with positive.
Alright, the normal.
The normal, which one? There's
The
three.
normal between B and C.
Give me the variable.
B2.
Okay, but we're doing some of the forces in the Y, and this is the Y-axis. So some of the forces in the Y are only the forces that are going in the Y.
The normal B1.
Right, NB1 minus WA minus WB equals 0, and in the end, what do we get? The normal of B1 is equal to WA plus WB. And we already know these, so we're going to know the value. And what do we want to call this? Maybe free body diagram AB. So which free body diagram do you like the best? I like this one the best because I could find NB1 already, right? I didn't have to do a high-level math, I didn't have to do system equations, I didn't have to plug it into my calculator. I could find NB1. Then, the sum of the forces in the x, you learn that these two are equal to each other, but they're both unknowns. We don't know what the value is. Hang on. So, then what do you want to do? Then which free body diagram would you use? Spencer?
So I was just thinking, so could you have done, if you did free body diagram A, and then that one is your second one, that would have been
Yeah.
better?
Yeah, there are the possibility of 3 free body diagrams. As long as you drew 2 and you knew you needed to draw 2, you're fine. You could solve the problem. But what I'm looking at is, how can we make the math easier? How can we make the math easier? In the end, we're finding that this free body diagram would have allowed us to solve for this right away. So now, looking at the other 2 free body diagrams, what would be the next equation you'd want to do?
I think that NA can be said that it's equal to the x component of NAB.
Okay, so the next free body diagram you're thinking about is this, and do the sum of the forces in the x. But I would have 2 unknowns in that equation, right?
But then you would substitute it with, like, it's the x component of the weight of A. So you can say that NA equals the cosine of the A.
Good. So how about, then go to this free body diagram and do sum of the forces in the y. And you find out that the y component of this is equal to this. And then once you have the y component, you solve for NAB, then you could do sum of the forces in the x and find what NA is. Then you could go back to that free body diagram and find out what NB2 is. What if we went to free body diagram B after this? What would you have done? So if you found what this value was, NB1,
So the sum of the forces in the y.
we could do sum of the forces in the y in free body diagram B and find NAB that way. And then we could do what? Sum of the forces in the x and find what NB2 is. And now that we have NAB, and we can do sum of the forces in the x here. Or, we already did sum of the forces in the x, we could do this. So, when you approach the homework 4, I noticed a lot of the problems you could solve without having to do systems of equations. Did you notice? There was usually one equation with one unknown. But sometimes the problems are more complicated. So in this case, looking back, what do you think? Should you just pick 2 free bodies? Should you just pick 2 bodies to analyze? Or do you want to think ahead and maybe decide which free body diagrams you want? So talk to the person next to you and rethink about how you would decide what to do next. And figuring out which free body diagram you want.